Good morning and warm welcome to all the students. Okay, in last two lectures we already have completed all the concepts from the of the force. Okay, that what is force, and we have seen that it's either push or pull. Okay, after it contact forces and non-contact forces. Okay, we have already studied the different types of contact forces and non-contact forces as well. Okay, now in this session we are going to study about pressure. Okay, that what is this quantity, what it's want to say, what is pressure. Okay, and mainly how the pressure is related to the force. Okay, how it's dependent on force. Okay, so first of all let me give you an example that all of you might have observed that when we are putting some force on this pointed nail. Okay, while we want to push it into a wooden plank. Okay, then if tell me that whenever we are doing this thing, then we are applying pressure on the head of this nail. Okay, we are not applying the pressure on this pointed nail. Okay, and why this happening? That only reason is that pressure is dependent on the area on which the force is being acts. Okay, as well. So there are two quantity mainly on which the pressure is dependent. That is force and area. So first of all, what is pressure? The force acting on a unit area. Okay, the force acting on a unit area of a surface is simply called pressure. So we can make an equation for it, that pressure equals to force upon area on which it acts. Okay, so if you take area as 1 unit. Okay, that unit area, it means 1 unit. Then force equals to pressure. Then this is how we are defining this pressure. That force acting on a unit area of a surface. Okay, observe here. If you take this area as 1 unit, 1 meter square, let's say, for a while. Okay, then force equals to pressure. Then so force acting on a unit area of a surface is simply called pressure. Okay, and we remember that what is the SI unit of pressure? It is Pascal. Okay, it is Pascal only. After it, what is the next topic? It is exerted by liquids and gases. Okay, so till now we are only we are only talking about the solid. Okay, so there is pointed nail. Okay, or anything, if we are cutting some vegetables by a sharp knife. Okay, so we are not cutting it by the flatted knife. Okay, we are only cutting it by the sharp knife. The only reason is that we just have to put very low pressure on it. Okay, so, what is the pressure exerted by liquid and gases? This topic wants to say. They have given you are given three activities in your textbook. Okay, and we will understand these activities here. First of all, this is activity 11.8. Okay, what it wants to say. Let me read out here. So let me read out here from this textbook. Take a transparent glass tube or a plastic pipe. The length of the pipe or tube should be about 25 centimeter, and its diameter should be 5 or 7.5, 5 to 7.5 centimeter. Also take a piece of thin sheet of a good quality rubber. Okay, you can take a balloon also for a while. Okay, say a rubber balloon. Stretch the rubber sheet tightly over one end the pipe. Hold the pipe in the at the middle, keeping it in vertical position. Ask one of your friends to pour some water in the pipe. Okay, after it, you can do it by yourself also. You can directly pour some water by from the tap also. Okay. Uh, Does the rubber sheet bulge out? Okay. Does the rubber sheet bulge out? Okay. You can simply observe here also that in this figure, in this given figure, you are given two different tubes, two different pipe. Okay. In which in first figure, in this figure also there are two figures of two different pipes. So in first figure the balloon is not so bulging, not so bulged out. Okay. But in second one it is. So why is this happening? That you can see this, you can see that in this first figure the water filled out in this pipe or in this tube is very less. Okay. Comparatively the second one, compared to the second one. So we can directly say that the pressure exerted by the water at the bottom of the container. Okay. Right now we are talking about the bottom because the rubber balloon is attached at the bottom side only. Okay. So the pressure exerted by the water at the bottom of the container depends on the height of its column. Okay. So it's very easy and very interesting activity. I think you all should perform this activity at home only. Next one is activity 11.9. So in activity 11.8, what we have seen it, what we have seen, it is the pressure exerted by the water at the bottom of the container. Okay. And what in this activity 11.9, it is about the a liquid exerts pressure on the walls of the container. Okay. So what actually they wants to say is they wants to say that if you are attaching a glass tube or a tube at the wall of a bottle or water bottle or a drink or soft drink, we can say. Okay. Thumbs up or Pepsi or 7 up, whatever. In that wastage bottle also, in that wastage bottle, make a hole at the side wall of the bottle and attach a glass tube or a tube with it. Okay. And same rubber balloon, attach a rubber balloon to it at the end of this another end of this attached glass tube. Okay. And as you will fill the water in this water bottle or soft drink bottle, you will observe that the balloon is being bulged out. Okay. And what is it? That it shows that this liquid exerts pressure on the walls of the container also. Okay. In activity 11.8, we have studied about this how this liquid exerts pressure on this bottom of the container. In activity 11.9, it is about the liquid exerts pressure on the walls of the container. Okay. So this is the activity 11.9. What is the second one? Third one. Third one is the 11 point activity 11.10, and it's want to say that liquids exert equal pressure at the same depth. Okay. कहता है कि लिक्विड न्याय करता है, वो अलग अलग नहीं रखता कि भाई मैं यहाँ पे थोड़ा सा प्रेशर, इस साइड पे थोड़ा सा प्रेशर, यहाँ पे ज्यादा था, यहाँ पे कम, ऐसा नहीं. ओके. Liquids exerts equal pressure at the same depth. If you are putting some holes in the water bottle. Okay. At the same depth from the bottom. Okay. Same depth from the bottom or the top, let's say. Okay. Then it exerts equal pressure at the same depth. Okay. So this is the very easiest activity you can apply at the home also. Okay. Now you might have questioned that, so what about gases? We have already studied for the pressure for the solids, uh, pressure exerted by the liquids. Now what about the gases? Simply let me give you an example of this rubber tube. Okay. Rubber tube of this of your cycle. Okay. When your cycle got a puncture in this wheel or in this tube, then what happens? You might have observed this figure only. Okay. Air exerts pressure on the inner walls of an inflated balloon or a tube. Okay. When you are applying some airs to the balloon. Okay. When you are filling this balloon, then what you do? If you apply some air to the balloon, after it you will close the mouth of the balloon. Okay. Why? Because the air will come out again. Okay. So this was the activity 11.10, by which they want to say that pressure exerted by the uh, air exert pressure on the inner walls of an inflated balloon or a tube also. Okay, so this was the basic of pressure. That what is pressure? Okay, what is pressure? It's simply a force exerted, force per unit area is pressure. Okay, it's simple. What is the SI unit of the pressure? It is Pascal. And already we have seen that how the pressure exerts by liquid and gases. Okay, so this was the basic of pressure. In next chapter, in next session, we will study about this atmospheric pressure, and we will revise the chapter and we will complete it. Okay, we will finish it. All of you are supposed to, all of you are supposed to do some work in Fairbook also, for which I will provide you some question answer. So this was the session in which we have studied about the pressure. Okay, thank you very much.